Friends, I'm going to review two particular types of problems in this video. I'm going to review those kinds of problems that have a fraction bar and that we're never sure, like, which am I really supposed to do first? How am I supposed to tell what order I'm supposed to use the order of operations? Because they both have fraction bars and I'm just not sure, Kate. So if you feel like these are the kinds of problems that have been tricky for you, you are in the right spot and we're going to talk through it. Okay? So the first thing I want to do is just remind everybody that when we're solving equations, solving an equation is like working backwards to solve a problem, right? We know what the answer is. In this case, the answer is -8, or in this case, the answer is 3. We know what the answer is, but we want to we want to retrace our steps, work backwards to try to figure out how we got there. How did we get to the answer? So when I look at a problem like this, or when I look at any problem, remember that if we're working backwards, we have to work backwards through the order of operations. So we remember that by the acronym SAD-MEG. Addition, subtraction, right? First thing we sort of dig at, then multiplication, division, look at that next. Then any exponents we can undo, and last of all, the grouping symbols. And these grouping symbols are what we really need to talk about, because the grouping symbols are what is confusing with these fraction bars. Because one of the things we need to remember is that a fraction bar itself is a grouping symbol. So if I were to have two different things on top of my fraction bar, this fraction bar is doing double duty. First of all, it says this is a division problem. You have to divide 8x plus 5. You have to divide whatever's on top by the 4. But it's also a grouping symbol because it's also holding together everything on the numerator or the denominator. And it's saying you've got to simplify one part, right? You've got to simplify the numerator before you can divide. Okay? And if I'm working backwards, that means that I have to undo this division before I can undo the grouping symbol. Okay? So let's take a look at these two different problems here, because these are problems that typically show up. And I'm just going to zone in, just like highlight the fraction bar for each problem. So if I look here, here's my fraction bar for this problem. And over here, here's my fraction bar for this problem. And there's a really fundamental difference between these two fraction bars. If I were to go in and put parentheses around what's in my fraction bar for each one, so that's for this one, and my parentheses here, is there any operation that I need to do inside these parentheses? No, not really. There's just a v. It's by itself. It's already simplified. So this is not being grouped. Right? This is just a division problem. But over here, because it's saying, hey, you have to do this addition inside the grouping symbol before you can move on, that is a grouping symbol. So when I'm solving these problems, I'm going to solve them a little bit differently because, again, I'm following SAD-MEG, but for one, I don't have a grouping symbol, and the other one I do have a grouping symbol. So you really got to check what is going on with your fraction bar. Okay? So let's take a look at this one. So I'm going to use SAD-MEG, and for this problem, I'm going to check first, is there any addition or subtraction that I can do with this problem? And if I look here, there's v is being divided by 3, and then added to -5 or subtracted by 5, however you like to think of that. And so here, that's a subtraction addition problem. So I want to undo my -5, or do the opposite of adding a -5. So I'm going to add a +5. And whatever I do on one side of that equal sign, I have to do on the other side of that equal sign. I'm just going to draw myself a nice little guardrail down that equal sign. So if I add those 5s to both sides, -5 and +5, those cancel out to 0. I am left with v being divided by 3, which is equal to -8 on that side. And now, if I take a look at this problem, I've got v divided by 3 is equal to -8. So I want to undo any multiplication or division that's going on. Well, here v is being divided by 3. So the opposite of dividing something by 3 is to multiply it by 3. And this one looks a little like a fraction, so I'm going to put those fraction pants on. And then on this side, I'm going to multiply this by 3. And because there's a negative involved, I like to put parentheses for my multiplication sign. So now I've got, well, that's going to cancel out down to 1. So we just have v left on this side. V is equal to negative 24. And then I can go ahead and check that and just say, is it true that negative 8 is equal to negative 24 divided by 3 minus 5? Well, hey, that's negative, that's not right. I must have made a mistake. Let's double check. So I must have made a mistake somewhere up here. So, here's why I know I made a mistake, because I had negative 8 minus 5 is equal to negative 8, and clearly that's not going to be right. So let's take a look. Let's see if we can find my mistake. I'm going to come in with a different color, maybe green. Green feels like a good mistake. Oh, purple. Purple feels like a mistake color. Okay, so let's see. I added 5 to both sides. I added 5, and I said negative 8 plus, look right there. That's a sign error right there. If I have a negative 8 and a positive 5, I could even think of that, right, with my negatives and my positives. Negative 8 and positive 5. That's not going to give me positive 8. That's going to give me, I'm sorry, negative 8. That's going to give me negative 3. And so now negative 3 times, oops, I wanted the eraser. Negative 3 times negative 3 is going to be negative 9. So negative 9 is v. Now let's check that. Get my eraser back out here. Is it true that 8 is equal to negative 9 divided by 3 minus 5? Well, that would be negative 3 minus 5 is equal to negative 8. And hey, that is correct. Great. Let's try this next one. So looking here, hey, there's a grouping symbol here. So sad Meg, this has to be the last thing I undo. So in order to think about sort of what's happening, this b first has to be added to the negative 1 and then be divided by the 5. So working backwards, is there any addition or subtraction that I can get to first? And the answer is no, because the addition or the subtraction is included in this grouping symbol, so I can't touch it at the beginning. So since I can't touch that addition subtraction, I'm going to look next and say, hey, there's a multiplication division problem going on here, because this grouping symbol is being divided by 5. So the opposite of dividing something by 5 is multiplying it by 5. So I multiply by 5 on one side. I'm going to squeeze it in sort of up here above the number. Multiply by 5 on that side. Now this side kind of looks like a fraction, so I'm going to put this fraction pants on. And so if I simplify these fractions, I'm left just with negative 1 plus b is equal to 5 times 3, or 15. Again, I'm going to put some guardrails on here. And now I'm going to take a look and, now there's no more grouping symbols, so I'm out. I ran out of sad Meg, right? Like, I've gone all the way through, but b is not by itself. It's not isolated yet. So I'm going to have to start again, right? I've taken away those grouping symbols, so now I can attack what's inside those grouping symbols. So now I can do the opposite of subtracting 1, which is adding 1. And so that 16 is equal to b. And let's check that. Is it true that 3 is equal to negative 1 plus 16 divided by 5? So is 3 equal to negative 1 plus 16? That's positive 15. Positive 15 divided by 5. I forgot my question marks. I forgot them over here too. Oh no. Okay. And so is it true that 3 is equal to 3? Hey, look at that. That looks true. Okay. I hope that was helpful. That was kind of fun. Just for the record, I did not make that mistake in the first problem on purpose. That is a mistake that I typically make. I have a tendency to make sign errors. And I'm actually kind of glad that that happened, because you get a chance to see what it really looks like to have to go back and figure out where did the mistake happen. Great. Thanks so much.